Okay, so to introduce myself, I'm Micheal Pelletier. I have been working with HTCondor since about 2013 and past attendee at a number of different Condor Week conferences. I work in the digital technology group at Raytheon Technologies, which is the new name of the company following the merger with United Technologies. And I work in the HPC group, which has recently been merged with the missile systems organization out in Tucson. So I manage a unclassified Condor cluster, and then we have a number of classified areas that use Condor as well. That's just a quick intro there, and I'll get right into the meat of the presentation. So for those who may not have like the IT background, I thought I'd explain this to some extent here. So a Dropbox workflow is when a file appears in a monitored folder, and the process doing that monitoring is called a watchdog, and that grabs those files from the inbox, so to speak, and processes them, and then launches, in this case, launches a processing job, and then that output is delivered to the final location. And so in order to implement workflows like this, you need a certain set of capabilities, both in processing and communication. You want to run the watchdog periodically, and you don't want, if it's running every 5 minutes, but it takes longer than 5 minutes, you don't want the next interval to step on the first one. You want to be able to distinguish between a watchdog failure and a processing failure. You don't want to overload your compute resources. You protect the input data and deliver the output successfully. You don't want to, if you're deleting it from the Dropbox after you submit it to the processing, you don't want to, you want to make sure that that input data stays intact until the job is successfully completed. And you want implementation simplicity. That's a key factor. And communication, you may have users who are using the outputs of this workflow. You want to be able to provide clear information about the state of the workflow to those users. You want to have the administrators keep on top of making sure that the watchdog is running. You want to deliver the output files to the final storage location, and then deliver a formatted report of processing to the stakeholders after each processing job completes. So there's the customary way that you would do this. I started working with Unix in 1984, so I go back a little ways. The main approach that folks tended to use over the years was creating a cron job to run that watchdog job. And so it has, as you can see here, it has a few different pitfalls. It's easy for one cron job to step on a previous one if you don't implement a locking mechanism within the processing job. There's no awareness or tracking resource utilization. There's no standard handling of in-progress input and output data. Communications have to be built into the processing code to generate notices, both in the event of a success and failure. And basically you have to do all sorts of things in your processing job that are complex to implement. And then, of course, distributing the work to multiple machines becomes a bit of a challenge as well. You have a small gain by using systemd. It manages the executables it starts and sort of shepherds them through the run. You can set up an on failure action to notify folks if the systemd fails, although you probably have bigger problems than that if systemd is down. And it can either run daemon style, where the watchdog code just sleeps periodically, stays up and running, or systemd can actually run intermittent application or intermittent executions of that job. There is some management of resources, but it doesn't track the overall utilization for the system. The workflow abstraction has to be implemented, here again in the Watchdog code, or the processing code rather. And then you have to still build all that stuff in, and you can't distribute work to multiple machines. So you wind up with sort of a Rube Goldberg device when, by the time you're all done writing the code that you need to implement these capabilities for a solid, supportable Watchdog code. So, like for instance, the mail sending, you might have to implement mailers in multiple programming languages. You have to manage the locking mechanisms, and ultimately you have a high skill set that's required to maintain it and to build a new workflow. So the approach that I took using Condor is based on the, it's sort of not the traditional high performance computing or high throughput computing approach, but it takes advantage of the Condor's abstraction of the job as a first-class object, and it's able to, and its abilities to notify users and things like that, transfer data, and so on. So basically, we've got the workflow system. You've got the Condor service, which is providing the framework for it. You have the Watchdog job, which is looking for new input in the Dropbox. And then the processing job takes that input to produce that output data. So not sure we need to really delve too deeply into this, probably not. It's, basically the key point here is that each member of the pool reports its resources, and the job queue is maintained by the schedule service, which, and then the negotiator matches the jobs in their resource request to available resources. So the submit description file is fairly straightforward. It's one big advantage. It's declarative, so you don't have to have things in a certain order. And it's just a set of simple key value pairs with types. So there's a lot more detail about that sort of thing in the Condor manual, so I'll refer you guys to that. So the Watchdog job has to stay in the queue after it finishes running, so that it can run again at the next Watchdog interval. So we want to set the on-exit remove option to false, so that the job doesn't get removed, but then goes back into the idle state. It also needs to know when to run, so you can say, you use a requirements expression. So this one, it says if the Watchdog interval has to be less than the current time minus the time the last job finished. And then here I've got this or last job status equals 5 or num job starts equals 0. That causes it to immediately run when after it's been released from a hold or first submitted. Basically the approach of having the Watchdog job exit means that the code is much simpler. It doesn't need to have a wait loop, things like that. It's akin to the initd services that some people may be familiar with. So the cron directives can provide a little more intuitive approach, but it doesn't run it immediately upon submission or when it's released from hold. So if you are running the Watchdog over and over again during debugging, you may find the requirements approach a little better. So this on-exit hold directive, when that becomes true, it will put the job into a hold state and email the notify user. So you've got the exit code, basically if any non-zero value is true for that. So if you exit with a non-zero code, it's going to trigger the on-exit hold directive. And the job stays in this held status unless it's released. And so you can also, you have the ability to release a held job if it meets certain criteria based on this periodic release statement. So, and so that's what generates the process, the distinction between the watchdog error and the processing error. And so the email system, the Condor uses relies on an installed email infrastructure on the server, on the central manager server. And so that's the nice thing there is that the way you set up the watchdog, you run it as a local universe job. And so the email from the watchdog will always originate, for Condor events, that'll always originate from that central manager or the scheduler, David, pardon me. So the watchdog job, you don't want it to, you want to set this notification to error because otherwise every time it runs, even if it doesn't find anything, it'll generate an email that the job's finished successfully. So here, getting a little further into the watchdog job, you run the watchdog code. Here's two different watchdogs, for example, that are monitoring two different Dropboxes. The watchdog can run either timestamp-based or deletion-based mode. So if you've got, say, a remote read-only file system that you've got some factory floor equipment that's adding files to it periodically, but you don't have, security doesn't want to give you right permission to delete files. If the files are actually being archived there, you can use a timestamp, so it'll gather everything that has appeared since the last time the watchdog ran. And then deletion-based is basically treating the Dropbox as an actual Dropbox, where it's, you take stuff out of it, delete the files after you take them out and pass them along to the processing job. So when the new input is found by the watchdog job, the watchdog submits a processing job. As you can see here, it generates this inputs, the inputs directive, and using the spool option, all the input files are copied into the varlib Condor spool path for safekeeping. It's basically buffer that the Condor uses internally. So that means that once the job has successfully been submitted, and you've got an exit code from, a zero exit code from the Condor submit command that the watchdog called, you know that it's okay to delete the Dropbox contents to prepare for the next watchdog run. And then by nature of how spool works, the files are kept in there until the job either completes successfully or is removed. You can also copy the runtime code for the processing job into the spool as well, which makes sure that if you're making code changes on your, on the directory, the changes won't affect a job that had been submitted with previous versions of the code. And then I wrote a submit mailer. It's kind of a huge inline shell script essentially. So I give it and it's actually applicable to any Condor job at all. I was hoping to get permission to disclose that code, but it takes a little longer to get that authorization through. So it, as you can see, you can submit it here with the target 14.2.16, and then basically it runs a Condor wait on the log file for that job. Pulls a lot of information from the job to, sort of understand what the job is and what it's doing. And then because of that, you can use it for any type of job. And then the mailer job, at the end of its operation, it can attach files or generate the email body from the job's output file. So that's been very convenient for these processing workflows. And so for the processing job, we've got it. We handed off the list of input files, and the files are in the spool. And once it launches, those files are copied to the job scratch directory, and then the processing job is launched in that scratch directory. The job generates gathers this input data and finds files to work on within it, that scratch directory, and generates the output there. And then when the job completes successfully, Condor's data transfer mechanisms kick in to deliver the output data back to the spool directory. And then finally, the Condor transfer data command brings the outputs from the spool directory to the job's original directory. So the Watchdog job calls Condor transfer data on any job. It's sort of like a backstop to ensure that any completed jobs have their data transferred. So here's basically the workflow. It's sort of, I think it'll help clarify what's going on. So the image over on the upper left is the silicon wafer die, and this actually calls out to the manufacturing process that this workflow system was developed on, where they're looking for voids in thermal paste using X-ray inspection equipment for the wafers. And so you've got the inspection machine. It takes its photos and transfers those photos to the Dropbox. And then the Watchdog notices, hey, there's something in the Dropbox. I need to take care of that. It pulls the data from the Dropbox into these job submission. And then ultimately the submission is sent to the spool directory on the central manager. And then the job is submitted into the Condor queue. And then the central manager notices that there's a job waiting to run, tries to match it up with resources, and creates that job sandbox, a scratch directory. And so the data comes from the spool, gets transferred to the scratch base, processed, and outputs are generated. And then the outputs are transferred back to spool from the scratch base. And finally, the Condor transfer data command delivers the final output.
Sorry, Michael, you have 2 minutes left.
Yep, thank you. So the nice thing is that the processing code doesn't need to worry about any data movement and protection. It just has to deal with what's in front of it without having to address all of that other complexity that Condor takes care of. So you've got a number of advantages here. You've got that high quality vetted implementations of essentially these capabilities that are essential to a solid Dropbox workflow. You can monitor and manage it with simple commands. Condor Watch Queue looks like an interesting new development. You protect that input and output data integrity. You can even encrypt it if you set up that option for Condor's scratch directory and data transfers. And then you've got all that the tracking that we're all familiar with, and the ability to transparently distribute work across multiple machines. So say you have like 2 different GPU servers, and the processing job doesn't need to worry about that. And a large global user community, which is all of you and the Condor users mailing list to help you out, as we all know. So thanks. I hope that that made sense, and I'd be happy to take any questions.